So let's start just at the bottom here, and let's just get a couple of guidelines going that are at this 30-30 relationship. You can also, with the parallel glider, you can see every parallel glider. This is my very cute one, right? He's quite fabulous here. Every parallel glider of this brand, from the Alvin brand, comes with its own protractor. So you can set this up. You can actually create the 30-30 relationship very quickly just with the parallel glider because it comes with a protractor built into it. But the graph paper obviously achieves that for us. Now, let's assume that every square is 1 foot. So whatever particular scale that we're actually working on is relative to the size of the graph paper. So let's just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's just make a 10-foot by 10-foot arm. So an arm going this way to the right 10 feet. Let's make an arm going this way to the left 10 feet. And use the graph paper as reference. So whatever scale that graph paper is, however it came out of the printer, looks like 1/4 inch. So we are basically at 1/4 inch equals a foot. Let's assume that this is just these are 2 by 12s coming together. And that they are resting on concrete post holes. So they do make isometric circle templates, but you can just eyeball this and then bring down a concrete post hole to the ground. At this point, you can either use a brake line, nothing at all, right? So you could use a brake line, or you could start to bring in landscape graphics and show it resting there on the turf, if that's what it's resting on. Different choices that you can make in terms of how you represent your design resting on the ground. Immediately now I'm interested maybe in pulling off a component. So I use a dashed line over here, and let's think about maybe a 4-foot staircase going onto this 2 by 12. So using the dashed line, we communicate to our viewer that we're pulling something off of something. And then I begin now a staircase, a simple staircase. This is the first tread. Typical tread height and length for residential. Do we know this yet? 7-Eleven. Just think of the convenience store. So typical residential is going to be 7-Eleven. So 11-inch tread, 7-inch riser. If you measure the steps here at CAP, probably a little bit different. They fall around 612, right? So if you start measuring some of the risers and treads here at CAP, they might be 612. So at any rate, the risers have to add up to your floor-to-floor, finished floor height, no matter what. So I can start to pull off now a little staircase as the first component of our explosion. It's also a part in our kit. Okay, so that's been pulled off now right off of our 2x12. Let's fill in the other two sides very lightly, because we're going to explode more layers off of that. Right? I don't want to get into too much detail or too much line weight back here because we need to pull off a floor pretty soon. So that you want to decide the degree of explosion or the distance of explosion. Maybe that has a logic to it that you're interested in. I'm just going to pull off the floorboards off of my floor joists like so. And I'm going to start the floorboards just at, three squares up, something like that. That way, now as I continue to work on my floor joists, I'm not tempted to draw all of them, only the portion of the explosion that's visible. And so maybe I have floor joists running at a particular interval that might be 16 inches on center, might be 24 inches on center. The grid paper is very helpful, particularly since I forgot to put on my glasses. Just draft in my floor joists underneath that. I'm using the very advanced technological tool of the Dixon Ticonderoga, which is my favorite pencil. Number 2 soft. Can't go wrong. Great American pencil. And then we'll see the depth of our 2x12 joist back there, and we'll see our floor joist connecting to it. Those might be 2x6s, they may also be 2x12s, whatever they end up being. Just fill in that third line now of the floor joist. And remember, I can always add line weight. Add line weight with pencil or pen to continue to create emphasis on those edges that receive the line weight. Frank Ching does a great job of explaining the logic behind line weight and which lines and surfaces get the line weight and which ones do not. So read up on that in design drawing for an explanation on which lines get the thicker line weights and which ones do not. I have a simple rule of thumb for how that works. I call it the knuckle rule. So these knuckles right here, if you were to grab that floor joist and the knuckles are pointing away from you, it gets a thicker line weight. If you were to grab that floor joist and that middle line there, the knuckles are pointing to you, they get a thinner line weight. So, as you look at the rules of line weights, start developing your own rules of thumb so that you can remember them and apply them to your drawings. Of course, if we were to do this in Revit would do it all for you, right? They would pick out the line weights and everything for you. Those would all be set as part of Revit's standard package of tools. All right, so here are the floorboards. So the floorboards might be 2x4s if we're just looking at a simple deck. So I'll draft that in, and then I'll draft in a portion of the floorboards, the remaining opposing 2 lines, but not all of it. Maybe, should we put maybe an enclosed space over here somewhere. Should we start thinking about that maybe? So let's say a portion of our there's maybe decking on two sides, and maybe we start thinking about a placement of a enclosed portion of our pavilion here. I'm just going to lay in some dashed line to remind myself that that's where it's going to go. And then I'm going to pull some dashed line up to continue our exploded drawing. And then start the wall, which is exploded. It's sitting on this deck, but we've exploded it up. I'm going to start these walls now until I decide how big this thing actually is. Okay. Now, how tall does it have to be? Let's assume these are 1 foot squares. 3, 4, 5, 6.